Alright, this is the practice exam. You'll get a cover page like this that's got the strong acids as the strong bases and some of these polyatomic ions on it. You'll also have your periodic table with more of those pieces on it as well. So here we go with a lot of the sample questions and a bunch of the answers explained. First of all, there are blank moles of carbon atoms in 4 moles of the C2H6SO. So 4 times 2 is equal to 8. So there are 8 moles inside there. Number 1, the molecular weight of methanol, rounded to the nearest integer, is, well, you need your periodic table for this. And so methanol is CH3OH. Carbon is 12, hydrogen is 1, there's 4 of them total, plus 16, and that adds up to 32. I got those numbers by looking on the periodic table and looking at the atomic mass for each one of the elements and adding them together. So 12 plus 16 plus 1 for hydrogen. Number 2, mass of 4 moles of the C2H4, so 4 moles, and then we have to add up C2H4 on the periodic table. Carbon is 12 times 2 plus 4 more for hydrogen. We multiply that times 4 and it ends up being 112. Number 3, the mass of 1 molecule of C2H4O is, so start with 1 molecule of C2H4O. We want to know the mass, so if you're following along with your periodic table, you're right here in molecules. We're going to go 2 moles and then we're going to go to mass. So molecule down here is a new set of units, and they're in 1 mole are 6.02 times 10 to the 23rd molecules. And then we're going to go from moles to grams of the C2H4O, and this adds up to 44 grams on the periodic table with 2 carbons, 4 hydrogens, and an oxygen. Multiplying those all together gives me 7.31 times 10 to the negative 23rd grams in 1 molecule. Number 4. The moles of carbon dioxide in 22 grams of carbon dioxide. Well, 22 carbon dioxides, there's 44 grams in 1 mole of carbon dioxide. When I add up 1 carbon plus 16 times 2, that gives me that. I got those numbers from the periodic table, and so it ends up being 0.5 moles. Number 5, how many grams of hydrogen are in here? In 16 grams. So the best way to do this is probably do the percent. So in 16 grams, the part divided by the whole of CH4O, the part that's hydrogen, multiply it by that fraction. And so the part that's hydrogen is 4, because hydrogen is 1 on the periodic table. And then you have to add up the whole thing on the periodic table, which is 12 plus 4, 12 for carbon, 4 for the 4 hydrogens, and 16 for the oxygens. So that's 32. So 4 divided by 32 times 16 ends up with 2 grams of hydrogen inside of there. Next problem, 6. What is the empirical formula of a compound that contains 40%, assume 100 gram sample, so it's 40 grams, 6.7, assume 100 gram sample, so it's 6.7 grams, and 53.3 grams of oxygen, assuming 100 gram sample. So take each, convert to moles. In hydrogen there's 1 gram, in carbon there's 12 grams. In oxygen, 1 mole oxygen, there's 16 grams. And using a calculator that's covered up by a piece of paper here. 40 divided by 12 is 3.33. This is going to be 6.7, and I believe this ends up being 3.33 as well. So we divide by the smallest, so divide by 3.33. We end up with carbon being 1, hydrogen being 2, and oxygen being 1, and that's our empirical formula. Number 7, the mass percent of oxygen in carbon monoxide. So carbon monoxide is CO, and it wants to know the percentage of oxygen in there. So we take part divided by the whole thing times 100%. So the part would be 16. Add those two together, 16 plus 12, we get 28. So 16 divided by 28 ends up being 57.1%. Don't forget you have to multiply this by 100 to get that percent, otherwise it's just a fraction. I mean just a decimal. Number 8, the molecule has an empirical formula of CH2 and a molecular mass of 28. What is its formula? So empirical formula mass times some number x is equal to molecular formula mass. So our molecular formula mass, it says, is 28. We have to find this x because that's what we'll multiply each of these subscripts by to make the molecular formula. And the empirical formula mass we get from adding this up on the periodic table. So carbon's 12 and hydrogen is each 1, and there's 2 of them, so it's 14. 14x equals 28. X is then equal to 2. So that means we need to take the subscripts, which are CH2, 1 and 2, and multiply them by 2. That ends up being C2H4. That's number 8. Number 9, stoichiometric calculations. Number 9, how many moles of O2 are produced when 0.25 moles of KO2 reacts in the following manner? So we put KO2 as our well, let's go through the steps again just so everybody's aware of those. Remember, the steps for stoichiometry are to have the balanced chemical equation. That's done for us. Step number 2 is to convert to moles. If we're given 2 amounts of substances, we need to do step 2.5 to determine the limiter, but we're not in this one. In step 3, mole to mole ratio. So in this one, we're just jumping right to step 3 because they just give us the moles right here and we only have one amount. So the mole to mole ratio is between KO2, and then what we want is the moles of O2. So for every 3 O2s, there's 4 KO2s. I get that from the coefficients in the equation. And so then 0.25, 3/4 of that is 0.1875 moles of O2. And it just asks for moles, so we're actually done right there. We don't have to convert to any asked for units. Number 10, how many moles of NH3 can be produced? So once again, we're given the balanced equation already. It's already converted to moles for us right here with 6 and 9. We do have to do step 2.5 though, because one of them is going to limit. So we'll take our 6 moles of N2 and our 9 moles of H2, and then we'll divide those each by the coefficient. For nitrogen, the coefficient is 1. For hydrogen, the coefficient is 3. This ends up being 3, which is smaller than 6, so my limiter right here is H2. So H2 then, as my limiter, I'd start with the 9 H2s, and then I would relate the H2 to the NH3 that I want to know. And the NH3 is a 2 in front of it, and the H2 has a 3 in front of it. So 9 times 2 divided by 3 ends up with 6 moles of NH3 as my amount of NH3 that can be produced. And notice they just ask for moles of that, so I don't have to do the last step where I convert to the asked for units. Number 11, calculate the moles of excess reagent remaining. So the excess reagent remaining, it obviously is nitrogen. but I need to figure out how much nitrogen is used to subtract from that. So I start with my limiter, because I always start with my limiter, because that's the thing that decides what's going to happen with the reaction. Put my limiter down here, and then put my excess reagent, the thing that I desire to know, right up here. And so my nitrogen right here is a 1. My hydrogen is a 3. So 9 times 1 divided by 3 is 3. So 3 moles of N2 will be used. Now I need to find the difference between these 3 moles and the amount that I started with. So 6 minus 3 gives me 3 moles that is left over. That's the first page.